All right, good morning, class. This is January 23rd, Monday. This is your Unit 3 or Week 3 of ST120. So we are going to talk about decontamination and disinfection of instruments. There are actually several chapters to go over in this entire week, so make sure you're reading those very carefully. We're actually going to be going over chapters 7 through 11. So here are your learning objectives for this week. You're going to accurately identify equipment and sterile supplies used in the OR or healthcare facilities throughout. Apply principles and techniques for proper decontamination according to industry standards. That's a big one. There's a lot of really important details in those chapters. Demonstrate the use of various chemicals and safety protocols used in decontam and sterilization. And again, throughout this entire course, you're going to learn how to demonstrate proper PPE because it's so important. So here are your assignments for week 3 or unit 3, found either under your syllabus or course modules. Make sure you're going through those and double checking to make sure you get those done, especially that discussion. Some of you are missing that Wednesday initial post, and then you would then respond by Sunday to somebody else. So watch those dates carefully and read the directions for each of those posts, the requirements that are due for each of those, because it is important. It's a big chunk of points you don't want to miss out on. All right, so our first chapter is chapter 7, decontamination, especially point of use, preparation, and transport. So we're going to discuss what each of those terms mean. So why is it important for central service techs to know how to handle decontaminated items properly? Well, I mean, obviously this is going to be the big part of your job, is getting back those dirty instruments. You want to make sure that you're handling them in a way that A, is going to keep the life of the instruments for as long as possible, and obviously to keep those clean and protect yourself, then also prepare them for sterilization in a way that is safe for the patients. So what is point of use, preparation, and transfer? What are the goals here? What are we trying to accomplish? So move my little screen over here. First, you're going to remove the gross soil. Usually that's the things that you can see. It's contaminated with patient's tissue, body fat, blood, other substances that you may or may not recognize. Either way, it's contaminated. If you can remove that gross soil first, it's then going to be a lot easier to clean. So other sources of contamination include used instruments and equipment. Even the case cart that those dirty things came back on are considered dirty or contaminated, and any other items that come back from other departments. So why do we do this? Why do we have point of use preparation? We also want to prevent instrument damage. Keeping those clean is also a good way of keeping them in functioning order to keep the instruments from being damaged. To prevent cross-contamination, you don't want to accidentally contaminate something that was already cleaned or sterilized with something that is dirty. And again, to keep others safe, not just you as the worker, but anyone else in your department. So really, what is point of use preparation? So this is a big thing, and this was, pounded into me as a surg tech, is that instrument decontamination begins at the point of use. So when the surg tech is using that instrument, or whatever department is using that instrument, as we're using it, we're wiping it down, keeping it clean. We're using sterile water to rinse it off. We don't want that tissue or whatever to get dried into either the clamps or into the shank, whatever it is of the instrument. It's going to make it a lot harder for the surgeon to use during the case, and it's also going to make it a lot harder for the sterile processing tech to clean it after. So again, we do it to prolong the life of the instrument. Metals can get broken down if we leave that bioburden like stuck on the instruments. Dried fluids and tissue are much more difficult to remove, so getting those moist with that sterile water, wiping those instruments down immediately after they're being used, will prevent that from happening. And then also, if you leave it sit for too long, tissue and moisture promote something called biofilm. A biofilm is just a microbiology term that means it's the way the bacteria adheres to a surface. It's like a protective mechanism from bacteria. That's something they do so that it's harder for them to die, but it's also harder for us to clean. So we want to make sure that we don't give them a chance to make that biofilm and help us make it easier to clean. So here are some guidelines for point of use. It isn't necessarily a replacement to the cleaning process. It's just one of the steps that's going to make it easier to clean. And it removes gross soil from instruments, like we said. Always follow IFUs. So it doesn't matter at what step you're in, you always have to follow the instruction for use. You always separate reusable sharps from other instruments. That is super important at any point. Point of use during cleaning, decontam, it doesn't matter. Always separate your sharps from others because you don't want to accidentally stick your hand into like a basin that was supposed to have the sharps removed and it didn't, and you get stuck. Maybe it was contaminated with HIV, you don't even know. So always take that step. That is an important safety precaution. You would separate out reusable linens. Those can go in a separate bin to go to laundry. Remove disposable items and place in a biohazard container. Those sometimes are things that come from the manufacturer that are pre-processed, pre-sterilized. They don't necessarily need to go to sterilization. They can just be disposed of properly. Whenever we're using these at point of use or at the end of a surgical procedure, we always open the hinged instruments. That way you don't accidentally miss it in the sterilization or cleaning process and it stays clamped. We want those hinges to get cleaned and sterilized within the hinge as well. Anything that came disassembled, you also disassemble at the end of use. Don't leave things put together. You have to clean each individual part if it is supposed to be disassembled. Another important one is heavy instruments on bottom and then put the lighter instruments on top, especially like during transport until you're ready to start the decontamination process. Obviously, this is for the prolonging the life of the instruments, making sure you don't damage those really delicate, fine instruments on the bottom by just throwing heavy stuff on top. Keep instrument sets together. Sometimes as a surg tech, this one is easier said than done. Sometimes you end up with a lot of trays during a case and it's hard to keep, okay, this instrument came from this tray together or vice versa. So that's important. And sometimes instruments are tagged specifically, but when it comes down to sterile processing for decontam, try to keep that tray cleaned at the same time so they don't get separated. It just prolongs the whole process if you have to go searching for something later. And again, keep instruments moist. Don't give that biofilm a chance to form. And then also during the point of use and decontam, you're going to tag instruments in need of repair. So if the surg tech in the procedure is upstairs and notices throughout the whole case, these scissors didn't cut well, or the surgeon complained these scissors aren't cutting right, instead of just sending them back down with nothing, they're supposed to put a little tag on it to make sure that they maybe get sharpened or sent to the instrument repair tech or something. So some other guidelines we have here. If it was used in patient care, you always consider it contaminated. If it was open on the back table, even if it doesn't necessarily wasn't used like within the patient, if it was open, it's contaminated. So it has to go through that whole decontamination process. Always wear gloves to pick up items. You know, if you're bringing something from the OR to decontam, wear gloves. Again, it's because we're considering it contaminated. If there is a basin of, let's say, fluid of some sort, it doesn't matter what, if any splashing is concerned, wear appropriate PPE. That definitely includes a face shield, eye protection. You want to protect your eyes from any splashing. And if you're transporting carts or using a cart to transport your supplies back to decontam, always pay attention to your path because not all facilities have their sterile processing department centralized. It may be farther away from certain areas that need things brought to sterile processing, and you have to push these case carts or whatever it is throughout the hospital to get to your department. So be careful with, I mean, you're going to have patients walking the hall. other employees. Sometimes you have a lot of turns. Hospitals are notorious for being mazes. So use your little mirror thing in the corner to double check, take your time, and just watch where you're going. Sometimes it's hard to push those carts. Never leave carts with soiled items unattended. Even if you just need to run in one room and come right back out, never do that. You don't know who's going to come by. Maybe they're nosy and come in, want to look, or you just never want to leave those unattended because they're dirty. All right, so let's talk a little bit about chapter 8, which is cleaning and decontamination. A lot of important info in this chapter that you need to read through. First of all, what's the definition of clean? It's not the excuse me, it's not the same as sterilization. We talked about that earlier. Sterilization means that it has no microbes whatsoever, including spores. But clean, you're just removing the soil, the gross debris, the foreign debris that shouldn't be there from the instrument. That includes visible and non-visible things. So sometimes, yes, we can see that an item is bloody. We're not going to consider that clean, right? We are going to remove that. You're going to go through that process of the washer decontaminator. That makes it clean, okay? So sometimes you can't even see it, but it still goes through the washer decontaminator, and we can then call it clean, safe to handle, right? We are reducing the pathogens by making it clean, but it doesn't necessarily negate the pathogens. There's still going to be some present, just like any surface that we touch now, that, throughout our house or whatever. It is clean, hopefully, but it is not sterile. You have to do it with the right tools to make sure it's considered clean. And if it wasn't cleaned properly, then it can't be sterilized properly. If you didn't clean it, maybe you had that hinged instrument shut, it didn't get left open, then it can't be sterilized properly. It negates the whole process and it has to be done again. Okay, so what's unique about the decontamination area? There are several things that are unique to this department. And remember, this is a separate area from the sterile side, or the side that's going to be doing the sterilization and reprocessing. This is the decontamination area that receives those soiled items from the different departments in the hospital, mostly coming from the OR, right? So your soiled instruments are going to start here, they're going to get cleaned here, and then they can go through that washer decontaminator to the other side for safe to handle. So there was that, you had your discussion board on the cost. Is it cost effective to centralize decontam? Is it a good idea to centralize decontam? So you guys had some really good thoughts on that process. Overall, it is generally more cost effective to centralize your decontamination department. Some of you were thinking outside the box a little and considered multiple facilities, and would there just be one central decontam for those facilities? And then maybe in that case, it wouldn't necessarily be cost effective. But if we're talking about just one facility, I think it probably would be more cost effective. That way, the entire hospital, all the supplies get run through here. You're not going to have duplicates. That's probably why they think this way. Location is important. Obviously, you want it to be close to where you're going to be receiving the most dirty items, which in most hospitals is going to be the operating room. Maybe even close to the ER. Those are the two probably biggest ones in most facilities, I would say. Sometimes you have multiple ORs on different floors, so somewhere in the middle would probably be ideal. Of course, that's not always possible, but that is ideal. So unique to the decontam, you have to have walls and floors that are going to withstand a lot of cleaning, because you're getting all those dirty things in. So they have to undergo a lot of chemical cleaning. So you wouldn't want wallpaper, those types of walls that don't wipe down very easily. Also, the air in the room is very particular. You have to have the right type of ventilation to get rid of any of those airborne microbes. So it is a minimum of 10 air exchanges per hour, and the room itself is under negative pressure. So what that means is whenever doors get open, the room air isn't going to go out. It's going to go the other way. It's going to go out instead of in. You don't want dirty things to come in. The temperature between 60 and 65 degrees Fahrenheit, that's important to minimize the growth of certain bacteria. Same with humidity. You don't want things to get too hot in there, and you're going to be hot under all that stuff, your gown and PPE as well. And the humidity needs to stay between 30 and 60%, again, to prevent microbial growth. If it gets too humid, that's basically moisture in the air, it's going to allow for some microbes to grow. But if it gets too low, it's going to allow for buildup of static electricity, which can then be a concern with starting fires. So another unique thing to decontam is the 3-sink arrangement. So what that means is you have 3 sinks for a separate purpose. The first sink would be considered the wash sink. This is where you're going to have water with a detergent or an enzymatic cleaner. The very first step in your process here. The water temp's a little warm, 80 to 110 degrees Fahrenheit. You don't want it too cold. Some of the heat will help destroy some of the microbes. Cleaners are going to be mixed per IFU, so whatever your facility uses, always check to make sure you got the right ratio, water to cleaner. Sometimes that does matter. And then your intermediate sink is a rinse sink, and now you're just using a plain water or a softened water, or you'll have a water softener. This assists in removing any of that, any of that built up cleaner that may have been left on it. It rinses it off, helps remove any excess debris. This sink, the water has to be changed pretty frequently. Your facility may demand maybe it's changed after every load, after every so many instruments. It just depends. The final rinse is your third sink. This water is a little bit different. Now you have to have distilled or deionized water, or possibly even reverse osmosis water. This is going to help prevent any chemical residue from building up, even though it's been rinsed. Sometimes it's left behind. That's why we do it 3 times, and prevents redeposit of minerals and microbes because of that type of water. So also in decontam, you have something called an ultrasonic cleaner. Sometimes they are referred to as sonics. This is used for fine cleaning, not necessarily for disinfection, definitely not for sterilization. And it's kind of unique in the way that it works. It's not just using plain water. It's actually, you put it in this machine, and it's basically going to have sound waves put into the water that we can't necessarily hear, but it produces enough vibration to cause something called cavitation. So cavitation, this term down here you need to know, is the process used by an ultrasonic cleaner that creates enough bubbles because of the waves that burst inward and help dislodge the soil from the instruments. So as it's like shaking it off with the sound waves, all the debris comes with it, which is kind of cool. If you're using any lumens, if you have like maybe a suction, you want to make sure fluid gets in that lumen. That way the bubbles get inside the lumen as well. Otherwise it's ineffective. And again, hinged instruments should always be open to reach every crevice of every instrument. All right, so what type of detergents are you going to be using during cleaning and decontam? These are your 3 main categories. You have a category called emulsifiers. These are used to combine things that don't normally combine. Like if you're thinking of a real life example, mayonnaise has like oil and water in it, but that doesn't mix. We know oil and water doesn't mix. So egg is sometimes added as an emulsifier to make mayonnaise. We have a couple drugs like that too. Propofol is one of them that needs an emulsifier. So you might have that type of ingredient to help bind those together for removal. And then you have something called a surfactant. This is a substance that lowers the surface tension of water, which helps increase its solubility so the detergents can work better. And then you have a chelating agent. This is a chemical that binds water to minerals specifically, and that helps prevent detergents from reacting with the minerals. So they all work by penetrating and removing soil from instruments, but you might have a couple different categories you use throughout. So here's some other cleaning guidelines for just the cleaning process. So we've talked about point of use. This is considered a pre-cleaning process. You're cleaning it before you clean it in a way. So as it's being used up in the patient's room or in the OR or ER, as it's being used, it's getting wiped down. That's pre-cleaning. Then manual cleaning is what you're going to do by cleaning by hand. You're going to have the 3 sinks, making sure that it goes through those processes and removing the debris that way. And you have a mechanical cleaning, which is using equipment. So the ultrasonic would be an example of a mechanical cleaner. Again, you're seeing this a lot because it's important. Hinged items always need to stay open. And sometimes they're easy to like accidentally ratchet shut. So, maybe throughout the whole process, you got to keep an eye on those. Sometimes they just kind of close back together, especially if they're being rustled around a little bit. Anything that has a bunch of parts, again, needs to be disassembled. So that way, disassembled, sorry. That way you can get into every crevice. Like, for example, some facilities use a Yonker, or sometimes it's pronounced Yankauer suction tip that is metal instead of the disposable plastic. Those have pieces that have to come apart in order for it to be sterilized again. Lumens always have to be flushed and then brushed, and you want to make sure that you're picking the appropriate size brush for the lumen. If it's too small and your lumen's like really big, obviously it's not going to clean the entire lumen. A lumen is like a hole inside of a tube, like a suction. If you're not picking the appropriate size brush, it's not going to clean the sides like it should. There might be a lot of left in buildup debris or something. Set aside non-immersible items. So you're going to get things back that are a little more delicate or maybe have video parts to it, scopes, that type of thing that have to be set aside. You can't just put that in a sink and immerse it in fluid or water. It would ruin it. So set those aside so it doesn't accidentally get put in the fluid. Ortho instruments require a bristle brush. Those are going to typically be your most contaminated items. Ortho surgery is notorious for being extra bloody. You're taking out bone. That bone can get lodged into different parts of the instrument. Just, rasping bone down. So you're gonna have a lot of bone pieces that is a little bit more difficult to clean. So a bristle brush is usually required for that. And again, always separate the delicates. It kind of sounds like laundry, separating your delicates from your others. So, and there's a reason for that. You don't want to damage those delicate instruments. You don't want to put anything heavy on top, but you also want to set them aside to maybe hand wash those separately to be very careful. All right, so chapter 9 is talking about disinfection. We talked about cleaning, then we can disinfect after that. So disinfection is the process used to make items safe for handling. The cleaning gets rid of that gross debris. Now we're going to disinfect it so we can handle it and then reprocess it. We want to repackage it so then it can go back into a sterilizer. Disinfectants are chosen based on something called the Spalding classification system. So that's an important thing to know because not everything is going to be processed the same way. So it depends on the type of item that you're going to have. So those classifications that you will need to know are non-critical, semi-critical, and critical. And it depends on how it's going to be contacted by the patient. A non-critical item would be things that have no contact with inside the body or cuts or incisions or even in the mouth, anything like that. It's intact skin. So that would be like your stethoscope, your blood pressure cuff, maybe a forehead thermometer. Those are non-critical. So it only requires a low level or maybe even intermediate level of disinfection. So if it is semi-critical, that means it's going to come in contact with a mucous membrane. So a mucous membrane would be like your mouth. It could be a vaginal retractor, that is considered mucous membrane, or even non-intact skin. Scopes are considered semi-critical, like an EGD, colonoscopy. So that would require a higher level of disinfection. So the appropriate solution would have to be chosen for those things. And then critical are things that absolutely have to be sterile because they're going inside the body. Those are the things we use for our open surgical procedures. We're making incisions. We're putting the instruments inside the body. So your picture here are retractors, graspers. This is even vascular system. So maybe if you're just making a small incision to go inside a vessel, maybe just putting in an IV. That item that you used to put in an IV, that hypodermic needle had to be sterile. So sterilization processes are required for critical items. So a couple of key terms here that you need to be familiar with disinfection. So anything cidal, if you see bactericidal, that means you're destroying or killing. Cidal always means killing. So relating to the destruction of bacteria. We want to get rid of those with our disinfection. So disinfectant is a chemical that will kill most pathogens, but remember, not spores, because the only way spores are killed is through the sterilization process. A high-level disinfection or disinfectant is the destruction of microorganisms in some spores, but not all. So the appropriate solution would have to be chosen for that. Intermediate level is going to kill some viruses, some bacteria, vegetative bacteria, but again, no spores. And low level is just some of the vegetative bacteria, some fungi, maybe some viruses. So not everything is going to get destroyed. That's why it's on those non-critical items that we would use that. All right, chapter 11 is a complex surgical instruments. There's a lot of supplies and instrumentation that you'll have to know. So if you're ever confused as to which way it needs to be sterilized and you're on the job, always make sure you reference that IFU, because there's going to be one for just about everything. So endoscopes are definitely complex because there's, for one, a lot of different types of scopes that have to be sterilized a specific way. And scopes in general are very expensive. So we want to make sure that we're taking good care of these to prolong the life of the instrument, help save the patients and the hospital money by keeping those sterilized, cleaned properly. So rigid endoscope, there's three categories: rigid, semi-rigid, and flexible. So rigid vary in size, they all vary in size, and typically that is in reference to the diameter. Sometimes it is in reference to the length, but usually referring to like how round it is. Constructed of stainless steel, these will not bend. That's why it's called rigid. We often prefer a rigid scope for if we're doing a laparoscopy, we're looking inside the abdomen. That's typically a rigid scope. Sometimes for cysto, you can do that. Arthroscopies, typically those are rigid. Semi-rigid vary in size again, but this is a little bit thinner, made of a thinner stainless steel. Just have some bend, but not a whole lot. You don't want to be like completely turning at 180 or 90 or whatever. These are going to be most often used in urology or like cystoscopy procedures. And then your flexible endoscopes, these are the ones that vary most often in length, because you're talking about gastroscopes, colonoscopes. Those are all within different lengths inside the body, so they have to come in different lengths. So those are the types of flexible endoscopes you'll see. They are easier to get inside those cavities. You can turn with the knob, the tip of the scope, so the surgeon can see different areas within the cavity. All right, so caring for endoscopes is a big process because you have those three different categories. They do have separate things that need to be done to them and may have separate ways of being cleaned. So just be careful of the ones that you're handling and what the process should be. Most of these scopes will have something that adapts a light source to it, and because they don't always adapt straight on. So make sure there's it's just a tiny little piece that is an adapter. Just make sure those are unscrewed. Sometimes there are extra valves, especially in cysto. They're going to be putting in like wires through those valves. Those have to come back off, colonoscopes, etc. Always use a neutral pH solution, and your IFU will tell you what type. You're going to start by hand washing it with a soft cloth, get any of that gross debris off on the outside. You're going to brush any working channel, like where the valves were, with, again, an appropriate size brush. And then you can flush the working channel, especially colonoscopes, gastroscopes, EGDs, those types of scopes will have those. You may not have a working channel on a regular laparoscope. They could. There's a couple that do, but more often than not, those are just an actual straight scope. You're going to dry it with a lint-free cloth. Lint-free is important. That way it doesn't accidentally get left on the instrument through the sterilization process. We don't want lint inside the body. Never place things on top of scopes. It's considered a delicate item. It's super expensive. It's easily damaged if you're not careful. So never ever place anything on top, and never coil anything really tightly. If it's one of those flexible ones, you want loose coils. And then with the flexible endoscopes specifically, these are the steps down here on this last one that you need to follow. First, you have to pre-clean, and then you're going to perform a leak test to make sure there's no leaks along the tubing. Then you can clean it according to IFU. You're going to use a high-level disinfectant to clean, really the word there should be clean, dry, and then you can store it. So that's our Unit 3 conclusion. So again, make sure you're reading those chapters. There's a lot of little nitty-gritty details in there that are gonna be important in your day-to-day function as a sterile processing tech. But if you have any questions, feel free to reach out to me. I do have office hours. If you need to meet outside those office hours, that's fine. Just send me an email or a message and we can try to work something out, probably through Zoom or whatever works for you. But education here brings about the opportunity and in turn inspiration. So again, you guys are actually, we're almost halfway through this quarter. I mean, you're in week 3 of 8. So you guys are on the right path. You guys are doing a really good job. I like reading your discussions. Make sure you're keeping up with the responses to your classmates. It's kind of a nice way to feel like you're still on campus. I know sometimes with online learning, it gets a little tricky. Sometimes you feel like you're alone. You're not necessarily a part of a team or a group, but you are, you have classmates that are going through the same thing you are. And, and sometimes as an instructor, it's kind of hard to be in contact with you guys, but I'm always here if you need to talk about anything. If you're struggling, let me know. We can work something out, okay? So I want you guys to have a good week. You guys are doing a great job, and I'll see you next week.